Welcome to recording number 2 in our series on illustrating how R and its various packages can be helpful in doing the work that we do in social work research and in other research as well. The first presentation we did an overview, sort of marketing for R, basically, and in this presentation we want to cover a few of the basics about using R, especially in the RStudio environment. So let's get started. We're going to try to do these in a fairly short fashion. So I'm pretty sure that people like yourselves with busy schedules aren't going to spend time doing an hour session. So we'll try to keep these short and maybe do a series. In fact, we will do a series that illustrate various parts of this. So this is the overview presentation that we want to do using R in the RStudio environment. So what you see on your screen is what you get when you open RStudio and sort of starting your analysis. Basically, there are 3 panes when you open up. You'll see in a minute that there are actually 4 panes or panels by the time you get started. But when you open it initially, without any saved workspaces, you get this look. So this is the console. This area here is called the console. It actually has a couple of other functions that it serves, but mainly we're interested in this as the console. And this is the view that you saw when you opened up R. So this is exactly what, if you were just to click on the R link and open up R, this would be what you would see. If you think about RStudio sitting on top of R, providing an interface to R, that's kind of a good metaphor. Basically, that's exactly what it does. This panel or pane is called the environment pane, and it serves a couple of functions. Probably most importantly in the sort of beginning stages of your work is that it will show some of the objects that you create when you do an analysis. And once we get into an illustration, you'll see how that looks. It's really kind of interesting, and it does serve a helpful purpose. I use it all the time. So some of these other tabs are, tabs that I don't use too much. You can actually get into a tutorial, and these will change depending on what you're doing, essentially. So if you're doing RStudio, our pubs, or using our Markdown, or Bookdown, these tabs change. But for the most part, they'll be, for the analyses that you do, they'll look like this. And then this is the files pane. And you can see that it's got a number of tabs and serves some purposes, as we'll see. Manage packages here, basically, and also it is a displayer for plotting that you do. I can't remember if I'm sure the plots show up in plots, but there is also another viewer that you can use. I actually don't use this too much. Mainly what I do is manage packages and look at plotting output. So that's kind of the navigation of the at least the initial startup. If you don't have a file loaded, what you'll discover is if you close out it typically will open where you left off. or it can open if you don't do some settings that we probably won't get into. I'll let you discover those, but it does show, sort of starts where you left off basically, which can actually be quite helpful. So let's just have a look at what it looks like when you open a file. I have a file that I have that we want to use, and we'll open it up and take a look at it. So when you open a file, the source pane then opens up. You can see what happens here, and it's pretty self-explanatory, I guess, in a sense it is. So this is an R command file, and all of these entries are commands, so that you'll have to learn. Set working directory is a command, load a library is a command, reading a data file is a command, fitting a model using MERT is a command, and you can sort of see how all that works, and we'll maybe do a little bit more detailed look at how some of these things work in the second or in the third video that we're going to do. In fact, that will be a good plan. So for now, we just want to sort of see how things work as an overview. So this essentially will get you started. One link that's pretty important you're going to have to sort of catch on to is, and I mentioned this before, R actually does its work primarily with libraries. So if you're going to, this is MERT is called the multidimensional item response theory package, MERT package, and it comes it's freestanding. It's not a part of the base package, basically. Phil Chalmers is a guy who maintains it. It's quite helpful in doing item response theory work. So you have to load it in an initial step, but even before you load a library, you actually have to install the package. And this is just a little link that's really, you have to really catch on to. So let's say you've discovered a package that you like MERT. What you have to do then is to install it into your user library. And it's a kind of one-time installation, process. And then once it's installed in your user library, you're able to call it through the library command in your R sequence, basically. So how you install a package is you click on package and go cleverly to install, and you'll get a dialog that looks like this. And if you should know your package. Actually, it's hard if you don't. You can type in MERT, and it's got a sound X, so it pops up, and so you'll get MERT, that command, and it's going to go off to one of the repositories essentially and grab MERT and install it. And so just click on install, and then there'll be a series of things down here that show up basically that tell you that it's installing, and does some fancy stuff that it does in the background that pretty much you won't need to understand, just to trust the fact that Phil has written a program that will install, and he has, basically. So you'll need to do that for every specialized package you intend to use. So for example, I use Lavon as a confirmatory factor analysis structural equation modeling library package, basically. So when I do CFA or SEM, I have to load that library. It can turn out that there are quite a few that when you do your work, you will end up installing typically more than one library in in your flow. And I'll plan to do a little bit more of an elaborate view of that as we do another module, basically. So this is really, once you get this all figured out, your syntax. This is an analysis. Let me just explain this. So this is an analysis file for a 4-item school connectedness scale that I was interested in. It's kind of classic, and I'm using item response theory to do this. So this is just a real quick example of what this looks like. So once you get there, you can highlight these and enter. I usually just do the run command here, and I do that line by line so I can kind of see what's going on. Once you get good at this, you can do it other ways, and you can sort of look at the directions about how to submit commands, but this is just the way that I do it. So if you click on run, you can see that it ran, and it shows up then in the console pane. So you can see that we've set the working directory to our training examples, and basically that our training examples is a folder. It's the folder that we loaded this command file out of, and so all of the data files and everything that you're going to do, it will be in that folder, and we'll call it, and it will then become the working directory. That's sort of the simple logic behind it. And once you catch on to that, it's really quite easy to do that, and to organize your work. If you keep things intact. M+ acts the same way. Typically, you have a directory in M+ that it understands and reads. So next we want to load our MERT library, and we click on that. And you can see that down below. These are dependencies, so it requires stats4, which is another package, and lattice, which is a graphics package that it uses. So lots of times packages use other packages to get their work done, and you don't really need to understand that. It just sort of tells you that. You will need to know about lattice graphics if you decide to use MERT, but that's totally for another day. So then we're going to read our data file, and you can see we're going to create an object called data, and this is a little assignment operator. Took me a while to catch on to the fact that you don't use equals typically in R. You use little left carets and dashes, little arrows, create little arrows. So what we're saying here is that we're going to create an object called data, and we're going to read a comma-separated values file called connectedness, and it's got some other things in here. Header equals true means that the variable names are in the first row, and it's comma delimited, as you can see there. So if you click on that, an interesting thing happens. Basically click on that, and you can see that we've actually created an object that shows up in our environment pane, and it's called data. So we did data here, and we have data here. And we can see that there are 1,664 observations and 5 variables. And if we click on this, we can take a look at it. And you can see that there are 4 items and gender as a demographic in the data file. And that makes lots of sense. And if you wanted to look at it in a viewer, if you click on data, it will show up being here in another tab in the source pane, essentially, so you can actually browse it. So you can go clear down to the end of it if you want to do that. And I do that sometimes. So so we're reading in the entire data file, but what we know is that we only want the first 4 items in our analysis. We're not interested in including gender in our item response theory So we need to kick it out. There are a number of ways to do that. One way is to connect, is to create another object, and we'll do that called connect, and essentially this command reads the data object that we created here, and it says collect, select columns 1 through 4. And if we click on that, we can see that that happens, and we can go to connect, and whoops, I just want to do the down arrow and it will show up. So tons of ways to work with files. As you would expect, R will read almost any kind of file you have. It really is, it isn't necessarily straightforward. You have to understand how to do that, and there are multiple ways to do that. So I just, I tend to catch on to what I know and use CSV files, which are really pretty general files. You can read SPSS files. I'm not sure about Stata. I'm sure you can. I just never have. So anyway, we get our data in, and we're ready to go. So now we're going to make a call to the MERT package here, the library or package here. You can see the command, and these are the arguments for MERT. So this says, run MERT looking at the connect data file, and our model will be just one factor model. Verbose really has to do with how the output looks on the bottom, basically, and we set it to false so we don't see a bunch of iterations. And then finally our item type for this, we'll get in, I don't know if we will ever get to IRT, maybe we will, but it's called, these are called graded response model items, Likert type items. So we make these arguments to MERT, and MERT's going to then generate an object called mod1 that has its own structure. And then what we'll do is use mod1 as we move along. So let's create that. And you won't really tell if it's created because at the bottom here, it doesn't really give you anything back. Typically when you create a model, it doesn't say anything except if it's a problem, and then it will tell you got a problem. So in this case, we don't have any problems. So one of the things that we do in item response theory is to check to see if the model fits the data, and this function here in the MERT package M2, it's called, is a model fitting function, basically. And you can see that it's going to operate on the mod1 object that we created here, and we're going to ask for it to do the type of model fitting index that we want is something called C2. This is just for example. So let's run that. And you can see now at the bottom here, this is where I mentioned in the first presentation that the output from R is not necessarily elegant, and this is kind of what you get, like lots of decimal points. You can actually set decimal points and things I did in here, but it's possible to tailor it a little bit, and there are other even better tools there. It's not impossible to do, but if you just use native output, this is what you'll get. And you can see these are just stats. This is an m-square. This is a chi-square-ish stat here with 2 degrees of freedom and a p-value, so it's statistically significant. So we would reject the model, the good fitting model, basically, and which happens all the time with large sample sizes. But we're interested in the root mean square error of approximation, which is 0.05. So this is a good model. And our TLI, Tucker-Lewis index, and conformist CFI, I can't remember what that stands for, are all good, and the standardized root mean square residual are all good. So this just an FYI. So this gives you some. So if you're writing an article, and I did write an article about this, this is the stuff that you would report in an article, and you know. So then, and so once again, it's not as elegant as you might get in SPSS or Stata, but it's definitely, you'll get the same answers. So there are two parameterizations in item response theory. One is a factor analysis parameterization, and the other is item response theory parameterization. So the factor analysis parameters, which are factor loadings and commonalities, are generated through the summary function, and you click run, and you can see that you get the loadings basically, and commonalities here, which is the squared loading. And proportion of variance, you can see here is like almost 70% of the variance, common variance, is explained by these factors. So it's really, you know, it's a good fitting model. And then we can take a look at the coefficients for this model by using coefficient method. It's actually called a method, and you can see we want IRT parse true, and we're going to simplify this and if we click on that, then we get our A and B parameters. Totally for another day, but this is just kind of how nice this is, basically. So you would be reporting these essentially in any article. Then we wanted maybe check item fit statistics, and we can click on our item fit statistics and get a nice little table here with some RMSEA values, which are all good. So really nice. So, you know, we're doing this with really pretty you know, really pretty terse syntax if you think about it. You can add, you can make it more complex by adding arguments, but typically you can get a lot by just a bare bones argument. So one of the strengths of R, as I mentioned at some point along the way, are the graphics that you get. And I'm just going to kind of run through these graphics. So these are commands for various commands and arguments. So this, for example, would be, and you can see that it pops up then in the plots viewer over here. So we get some nice, these are category characteristic curves, and then information curves. You can see we get, these are defaults, these are lattice graphics, and then we get information and standard errors, which is really nice. And then we get conditional reliability, which is great, and then we get our test characteristic curve, and then we get our standard error curve as well, which didn't pop up for, there we go. It pops up with, this is standard, these are the standard errors and the confidence intervals, which is really nice. So one of the things that you can actually do, this is probably a little more than we needed to today, but this is the nice thing about it. So all of these things in lattice graphics are actually objects, which means that you can change attributes. And if you get into this and get interested in it and want to learn how to do this, we'd be happy to help you. It took a while for me to figure it out, but it's really, once you figure it out, it's really pretty cool. So we're going to do a information and standard error curve, and we're going to do that with plot, but we're going to create an object called plot information SE cleverly. So let's just do that. And you can see that it gets created over here, and then we can take a look at it by just clicking on it. So that's what we get. And you can see that we have information conditional on theta and standard error conditional on theta. So let's say we want to change those and give them titles that are more informative, if you will. So we can do that through this little process here of actually changing those attributes. And I'm not going to do that all, but you can see what we've done here is to change the I conditional on theta, standard SE conditional on theta, to actually the labels. And that's super helpful. I have published a couple of articles using plots developed in R, and changed attributes and created plots that were camera ready. You can, create TIFF plots, or actually any kind of plot that you want, essentially. So it's really pretty cool. So then some other things that we can do is maybe use, so we're going to create some scores. I'm just showing you, so we want to create an object called scores. So we do that, and then we can bind that to the data, and then take a look at a histogram and a summary of scores. And then we can get something called empirical and marginal reliability, which are here and here. And you can see they show up down here. So that's an illustration of how you can use R to structure an analysis. In this case, we did an item response theory analysis of a short scale, and you can see how quickly things go. I mean, this is not a lot of commands. It's really, the language is pretty what I call terse. I mean, it can actually be complicated, I won't lie. But once you figure out the basics of it and get the documentation, the MERT documentation is extensive, and there are some nice books written about MERT that are really quite helpful if that's something that you get interested in, item response theory. So, but overall, what we really wanted to look at is kind of what happens in the R environment once we get once we decide what it is we want to tackle. So we create our commands here. It can be really iterative. You can do troubleshooting and things here, and you get information down here that helps you here. It's really very cool, and you can kind of keep track of the objects that you create, and you can see, you can close those up. You know how that works. It's really just wonderful, and the graphics are really pretty, are great. This actually is an internal graphic. It's not a lattice graph. These are lattice. These are extensions. These are lattice graphs here. Here, I'll show you, go back. So lattice, really, the lattice piece of this is that these ostensibly look like a lattice. That's what Bill Cleveland is, the kind of the originator of lattice graphics, basically. So he said, hey, it looks like a lattice for roses or something, I guess. Anyway, that's where the metaphor came from. So, so that's, just kind of a simple working session in a nutshell. Really, it's just, we just have to learn how to do it. But you can see that in how helpful RStudio is in terms of developing scripts and keeping track of what's going on in the analysis, and getting answers down here that you will then use in whatever your reports are. And also then getting graphs, if graphs are a part of the work that you're doing, that show up here. You can export these then. I do them a different way, but you can save them as an image or copy them to a clipboard and put them in a PowerPoint presentation. Just anything that you want to do with your graphs are really pretty is available. And you can also, as I said, output them. You don't have to do them as an export. You can there are some commands that you can include in your command file that will create some really very nice graphs. So I hope this is helpful, makes sense as a sort of preliminary overview. It's kind of the heart of it. Honestly, you could, if you got good at this, you could do just about anything you wanted to do. It really is, that straightforward. So, well, look for the second, I guess, third installment now along the way, and I'll see you then.